Solving an absolute value inequality. There are two examples here. They're both extremely different. They look similar, but they're actually extremely different because this symbol here is less than and this symbol here is greater than. I am going to give you a little bit of insight from calculus class on how to interpret the absolute value. So I'm going to rewrite this first one. Let's do example A. We're going to rewrite this a little bit differently. So the most instinctive thing to do is actually subtract 14 from both sides of the inequality. And we want the absolute value on the left side of the inequality. I am going to write this a little bit different. I'm going to write this as the absolute value of v minus 0 is less than 9. So how do we read this geometrically? How do we read this statement geometrically? We actually are reading it this way. I guess I could state it as a statement. I don't have to say it as a question. We want all the v values. We want all the v values centered at v equals 0 that are within 9 units. So what does that mean? I mean, if you had to draw this on a number line, how would you draw this? So you first draw a V number line, and that number line, well, the values that you're concerned about are centered at 0. So let's go ahead and draw the center. Our center is labeled 0 here. And we want all the V values that are within 9 units centered at 0. So 1 is going to be shaded. If we had 1 here, it's going to be shaded. Well, maybe that's not 1, maybe that's 2. I'm not going to draw this to scale. So 2 is going to be shaded. 2 is within 9 units. And this is a V number line, So we got to shade everything up to 8.999999999, right? So it makes sense to shade this way. And then you have to go all the way up to what? All the way up to 9, but don't include 9. Now, technically speaking, I should be shading from left to right. So I should have started this at -9. We don't include -9, but we shade all the way up to 0. And then from 0, we keep shading all the way up to 9, but don't include 9. So what is the answer to this? If I wanted to state the interval notation, it's simply -9 to 9. We solved this, and we actually labeled it in interval notation. What about this other procedure over here? Example B. You're first going to start off by subtracting 12. So now we have what? We have the absolute value of x minus 0 is now greater than what? 14. So these are all the what? These are the x values centered at x equals 0 that is more than 14 units away from 0. So can we shade 9? Is 9 relative to 0 more than 14 units away from 0? The answer is no. You can't shade 9. In fact, what's the first number you can shade? It's actually really, really hard to see. Can we shade, 26? Is 26 more than 14 units away from the center of 0? Can we shade 52? Is 52 more than 14 units away from the center of 0. So why don't we draw what we need to shade? So this time we're drawing an X number line. It's still centered at 0. And then we need to label some key values. And those key values are negative 14 and 14. We got to be more than 14 units away. So shading from left to right, we could shade what? Negative 2 million. We could shade negative 30 trillion. And we're going to go this way. And then we're going to put a parenthesis here. All those values would work. You know, if you don't believe me, put in x equals negative 25 in here. And then take its absolute value. Is it greater than 14? Yeah, of course it is. Now, we can't shade anything in here. If we put negative 6 in here, puts negative 6 in here, it doesn't work. Just does not work. It's not true, it's false, right? We always shade the true regions. So this is true. When else does it become true? It becomes true right here. And so this is the geometric interpretation that's very, very handy in a calculus class or a statistics class or any kind of B-STEM mathematics class. Circle our final answer.